Welcome to Intelligence Gateway.
Antivirus and Firewalls. Lecture 16.8. Topic objectives. TAS. Describe how antivirus software and firewalls can be used to secure IT systems. Antivirus software and firewalls are crucial components of cybersecurity that can be used to secure IT systems. They serve different but complementary purposes in safeguarding systems from various cyber threats. Let's explore each of them in detail. Antivirus software. Antivirus software is designed to detect, prevent, and remove malicious software, commonly known as malware, from computer systems. This includes viruses, worms, trojans, spyware, adware, and other harmful programs. Here's how antivirus software works to secure IT systems. Malware detection. Antivirus programs regularly scan files, programs, and the overall system for patterns and behaviors associated with known malware. They maintain a database of signature patterns for recognized threats. Real-time protection. Antivirus software typically operates in real time, monitoring activities on the computer or network. It instantly reacts to suspicious actions, preventing malware from executing and causing harm. Quarantine and removal. When malware is detected, the antivirus software isolates it in a secure area called quarantine to prevent further spread. Users can then decide whether to remove or restore the files. Regular updates. To keep up with new and emerging threats, antivirus software vendors release regular updates. These updates include the latest malware signatures and heuristic algorithms to enhance detection capabilities. Behavior analysis. Advanced antivirus programs use behavior analysis to detect previously unknown threats based on their behavior rather than relying solely on signature patterns. Firewalls. Firewalls act as a barrier between an internal network and the external world, such as the internet. They control incoming and outgoing network traffic based on predefined security rules. Firewalls secure IT systems by traffic filtering. Firewalls inspect network packets and data to determine if they should be allowed or blocked based on the defined rules. This process helps prevent unauthorized access to the network. Network segmentation. Firewalls can divide a large network into smaller segments, creating separate zones with varying levels of trust. This containment limits the impact of security breaches. Access control. Firewalls can be configured to allow or deny access to specific ports, protocols, or IP addresses, reducing the attack surface and limiting potential vulnerabilities. Application layer filtering. Next-generation firewalls can inspect the content of network packets, the application layer, providing additional protection against more sophisticated attacks. VPN support. Firewalls often support virtual private network (VPN) connections, enabling secure remote access to internal network resources. It's essential to note that while antivirus software and firewalls are effective in securing IT systems, they are not foolproof. To achieve a robust cybersecurity posture, organizations should also implement other security measures such as regular software updates, strong access controls, employee education on cybersecurity best practices, and routine system audits and assessments. A multi-layered approach to security significantly reduces the risk of successful cyber attacks. Merit. Explain the techniques used by antivirus software and firewalls to identify threats. Antivirus software and firewalls are crucial components in modern cybersecurity, aiming to protect computer systems and networks from various threats such as viruses, malware, and unauthorized access. Both employ different techniques to identify potential threats. Let's delve into each. Antivirus software techniques. Signature-based detection. This is one of the oldest and most common techniques used by antivirus software. It involves maintaining a database of known malware signatures. When the antivirus scans a file or program, it compares its signature with those in the database. If it finds a match, it identifies the file as malicious. Heuristic analysis. Unlike signature-based detection, heuristic analysis looks for patterns and behaviors common in malware. The antivirus software doesn't rely on exact matches, but flags suspicious files based on their behavior. For example, if a file attempts to modify system files or replicate itself, it may be flagged as potential malware. Behavior-based detection. This technique observes the behavior of programs in real time. If a program exhibits malicious behavior, such as attempting to access sensitive data or communicating with suspicious servers, the antivirus can block its actions and flag it as a threat. Sandboxing. Antivirus software may use a technique called sandboxing to isolate suspicious files or programs in a controlled environment. The file is executed in this virtual environment, and its behavior is closely monitored. If it displays malicious behavior, it is deemed a threat and dealt with accordingly. Machine learning and AI. Modern antivirus software increasingly leverages machine learning and artificial intelligence algorithms. These algorithms can analyze vast amounts of data and learn from patterns to identify new and emerging threats that may not have known signatures. Firewall techniques. Packet filtering. Firewalls use packet filtering to examine incoming and outgoing data packets based on predefined rules. These rules may include allowing or blocking packets based on their source, destination, port numbers, or protocol types. It helps prevent unauthorized access to specific ports and services. Stateful inspection. Stateful inspection examines the context of network connections. It keeps track of the state of active connections and ensures that incoming packets belong to valid and established connections. This prevents certain types of cyber attacks, like TCP/SY floods. Application layer filtering. Firewalls can operate at the application layer, layer 7 of the OC model, to analyze the contents of data packets. This enables firewalls to block or allow specific applications or services based on their content or behavior. Proxy service. Firewalls can act as intermediaries between internal users and external servers through proxy services. The firewall handles external requests on behalf of the internal network, providing an additional layer of security by concealing internal IP addresses and filtering malicious content. Deep Packet Inspection (DPI). DPI goes beyond simple packet header analysis and examines the payload of data packets. It allows firewalls to inspect the content of packets and make more informed decisions based on the data being transmitted. In summary, antivirus software focuses on identifying and eliminating malware threats that may already be present on a system, while firewalls concentrate on monitoring and controlling network traffic to prevent unauthorized access and data breaches. Together, they form a critical defense against various cyber threats and attacks. Distinction. Evaluate how effectively antivirus software and firewalls keep data safe. Antivirus software and firewalls are two crucial components in the realm of cybersecurity that help protect data and systems from various threats. Let's evaluate how effectively each of them keeps data safe. Antivirus software. Antivirus software is designed to detect, prevent, and remove malicious software, such as viruses, worms, trojans, ransomware, and other types of malware. Here's an evaluation of its effectiveness. Pros. A. Malware detection. Antivirus software can efficiently detect known malware signatures, thanks to regular updates of virus databases. Real-time protection. Many antivirus programs offer real-time scanning, which helps identify and block threats as they attempt to enter the system. Behavioral analysis. Modern antivirus solutions use behavioral analysis to detect suspicious behavior patterns, even for previously unknown threats. Cons. A. Signature-based limitations. Traditional antivirus relies on signature databases, making it less effective against zero-day attacks. Newly discovered threats. Performance impact. Some antivirus software can slow down system performance, especially during scans or real-time protection. Overall, antivirus software is valuable for detecting and removing known malware, but its effectiveness can vary depending on the software's quality and how quickly it can adapt to new threats. Firewalls. Firewalls act as a barrier between a trusted internal network and an untrusted external network, typically the internet. They control incoming and outgoing network traffic based on pre-established security rules. Let's assess their effectiveness. Pros. A. Network traffic filtering. Firewalls inspect incoming and outgoing data packets, allowing only authorized traffic and blocking potentially harmful or suspicious packets. Protection against unauthorized access. Firewalls prevent unauthorized access attempts to the network, reducing the risk of data breaches and unauthorized system access. Segmentation. Firewalls enable network segmentation, isolating critical data and systems from less secure parts of the network. Cons. A. Incomplete protection against internal threats. Firewalls can't defend against threats originating within the internal network, such as insider attacks or infected devices within the network. Advanced attacks. Sophisticated attacks can bypass traditional firewalls by using encryption, tunneling, or other evasive techniques. Specification coverage. Introductory task. Have you ever heard of antivirus and firewall software? Yes, as an AI language model. I am familiar with antivirus and firewall software. These are two essential types of cybersecurity tools used to protect computer systems and networks from various threats, including viruses, malware, and unauthorized access. Antivirus software. Antivirus software is designed to detect, prevent, and remove malicious software, viruses, worms, trojans, spyware, adware, etc. from a computer or device. It works by scanning files and programs on the system for known patterns of malicious code. When a virus or malware is detected, the antivirus software can either quarantine the infected file or attempt to remove the threat entirely. Regularly updating antivirus software is crucial to stay protected against new and emerging threats. Firewall software. A firewall is a network security device or software that monitors and controls incoming and outgoing network traffic based on predetermined security rules. It acts as a barrier between a trusted internal network and untrusted external networks like the internet. Firewalls can be hardware-based, a physical device, or software-based running on a computer or server. They work by examining data packets and blocking or allowing them based on specific criteria or rules, such as source, destination IP addresses, ports, and protocols. Firewalls are an essential line of defense against unauthorized access, hacking attempts, and other network-based threats. Deeper learning activities. Antivirus software. Describe what is meant by the term antivirus software. PAS. The term antivirus software refers to a type of computer program designed to protect a computer system or network from malicious software, commonly known as malware. The primary purpose of antivirus software is to detect, prevent, and remove various types of malware, such as viruses, worms, trojans, spyware, adware, and other potentially harmful software. Antivirus programs work by employing various techniques to identify and neutralize malware threats. These methods typically include signature-based detection. Antivirus software maintains a database of known malware signatures. When a file is accessed or executed, the antivirus scans it and compares its digital signature to the ones in its database. If it finds a match, it flags the file as malware. Heuristic analysis. Antivirus programs use heuristic algorithms to identify potentially new or previously unseen malware based on suspicious behavior patterns. This helps detect emerging threats for which specific signatures might not yet exist. Behavioral monitoring. Modern antivirus software monitors the behavior of programs in real time. If a program exhibits suspicious behavior, such as attempting to modify system files or accessing sensitive data, the antivirus can block or quarantine it. Describe what is meant by the term virus signature pass, and explain why antivirus software makes use of it. Merit. A virus signature, also known as a malware signature or a digital signature, is a unique pattern or characteristic code within a computer virus or other types of malware. It serves as a specific identifier that allows antivirus software to recognize and detect the presence of known malicious software on a computer system. The signature is essentially a fingerprint or a set of attributes that distinguishes one malware variant from another and helps antivirus programs in identifying and combating them. Why antivirus software makes use of virus signatures? Antivirus software relies heavily on virus signatures for malware detection and prevention for several reasons. Identification of known malware. Virus signatures are created by security researchers and antivirus labs after analyzing and reverse engineering various malware samples. When a new virus or malware variant is discovered, its unique signature is added to the antivirus database. This enables the antivirus software to quickly recognize and classify known malware during system scans. Rapid detection and response. Virus signatures allow antivirus software to swiftly identify and block known threats without relying on time-consuming deep analysis of the malware's behavior. By matching incoming files and data against the vast database of signatures, the antivirus software can act immediately if a match is found, providing real-time protection against known threats. Efficient resource usage. Using virus signatures is a computationally efficient approach for antivirus programs. The signatures are usually compact and can be stored in a database, requiring relatively little system resources to perform scans compared to more resource-intensive heuristic or behavioral analysis methods. Zero-day threat mitigation. While virus signatures are effective against known malware, they may not detect brand new, unknown threats called zero-day threats. However, they can still be useful in identifying elements of zero-day attacks and preventing some parts of the malware from executing, complementing other detection techniques. Antivirus software often uses multiple detection methods to enhance security. Virus signatures work in conjunction with heuristic analysis, behavioral analysis, machine learning, and other techniques to provide comprehensive protection against a wide range of threats. Limitations. Despite their effectiveness in detecting known threats, virus signatures have some limitations. Inability to detect unknown threats. As mentioned earlier, virus signatures are only effective against known malware variants. They are powerless against new or modified malware that does not match any existing signature, which is why other detection methods are crucial to address zero-day threats. Signature updates. Antivirus software needs regular updates to maintain an up-to-date database of virus signatures. If users fail to update their antivirus software regularly, it may not detect the latest malware threats. In conclusion, virus signatures play a vital role in antivirus software by enabling the rapid detection and blocking of known malware, complementing other detection techniques, and efficiently utilizing system resources. However, they are just one part of a comprehensive security approach, and antivirus programs must also employ other methods to protect against emerging and unknown threats. Describe what is meant by the term heuristics pass, and explain why antivirus software makes use of it. Merit. Heuristics, in the context of computing, refers to problem-solving techniques or algorithms that use practical, intuitive, and efficient strategies to find approximate solutions when an exact solution is either not feasible or too time-consuming. The term comes from the Greek word heuriski, which means to discover or to find. In the field of artificial intelligence and computer science, heuristics often involve using rules of thumb, educated guesses, or past experiences to guide the decision-making process. The term pass is not commonly used in the context of heuristics, so it might be a specific acronym or a reference to something particular that falls under the broader umbrella of heuristics. However, I'll explain heuristics in general and then touch upon why antivirus software makes use of heuristic techniques. Antivirus software and heuristics. Antivirus software is designed to protect computer systems from various malware threats. including viruses, worms, Trojan horses, and other malicious software. Traditional antivirus solutions primarily rely on signature-based detection, where they identify known malware patterns by matching them to a database of signatures. However, this approach has limitations. Signature dependency. Signature-based detection is only effective against known malware, for which signatures have been created. It cannot detect new or unknown threats that have not yet been identified and added to the signature database. Zero-day vulnerabilities. Zero-day vulnerabilities refer to newly discovered software flaws that have not been patched by the software developers. Malware exploiting these vulnerabilities can go undetected until security updates are released. Polymorphic malware. Some malware is designed to mutate or change its code slightly to evade signature-based detection, making it harder for traditional antivirus programs to recognize them. To address these limitations and improve their detection capabilities, modern antivirus software makes use of heuristics. Here's how heuristics are employed. Behavioral analysis. Heuristic-based antivirus programs monitor the behavior of programs and processes in real time. If a program exhibits suspicious or malicious behavior, e.g., attempting to modify system files, replicating rapidly, trying to access sensitive areas of the system, the antivirus software may flag it as potentially harmful. Code analysis. Heuristic algorithms analyze the code of files and programs to identify suspicious patterns or behaviors that might indicate malicious intent. For example, a heuristic engine might identify certain sequences of instructions commonly found in malware. Sandbox testing. Some antivirus solutions use virtualized environments called sandboxes to run potentially dangerous files or applications in isolation. By observing their behavior in a controlled environment, the antivirus can assess whether they exhibit malicious activities. Generic signatures. Heuristic-based antivirus can use generic signatures that target certain classes of malware, rather than specific instances. For example, a heuristic signature might detect any file attempting to modify multiple files at once, which could be indicative of ransomware behavior. Research and evaluate how effectively antivirus software improves the security of a network. Distinction. Research and evaluating the effectiveness of antivirus software in improving the security of a network involves examining various aspects related to its performance, impact, and limitations. Below is a comprehensive analysis how antivirus software contributes to network security, detection, and prevention. Antivirus software's primary function is to detect and prevent malware, viruses, and other malicious software from infecting the network. It does this by scanning files, email attachments, and downloads in real time. Effective antivirus solutions have large signature databases and heuristic analysis capabilities that can identify both known and previously unseen threats. However, it is important to note that no antivirus software can guarantee 100% detection. Real-time protection. The ability to provide real-time protection is crucial in dealing with zero-day threats. A well-implemented antivirus solution can quickly identify and quarantine suspicious files or activities, thereby mitigating potential damage. Updates and database maintenance. Antivirus software must be regularly updated to stay effective against newly emerging threats. The frequency and efficiency of updates are vital. In maintaining a strong defense, trusted vendors continuously research and release new virus definitions and updates to performance impact. Antivirus software operates in the background and consumes system resources, potentially affecting network performance. However, modern antivirus solutions are designed to be lightweight and less intrusive, minimizing impact while maintaining robust security. False positives and negatives. An ideal antivirus strikes a balance between avoiding false positives, flagging legitimate files as malicious, and false negatives, failing to detect actual threats. Too many false positives can create user frustration and operational challenges, while false negatives compromise security. Describe what is meant by the term firewall software. PaaS. A firewall is a type of software or hardware-based security system designed to monitor and control incoming and outgoing network traffic. Its primary function is to act as a barrier between an internal network such as a company's intranet or a home network and the larger, external network, usually the internet. The main goal of a firewall is to prevent unauthorized access to the internal network, while allowing legitimate communication to take place. Here's a more detailed explanation of what is meant by the term firewall software. Security barrier. Think of a firewall as a virtual wall or barrier that sits between your computer or network and the internet. It carefully examines every data packet that attempts to pass through it, deciding whether to allow or block the information based on pre-configured rules. Traffic monitoring. The firewall continuously monitors all incoming and outgoing data packets, checking their source, destination, and content. It uses a set of rules to decide which packets are safe to pass through and which ones should be denied. For example, it might block certain websites or specific types of files known to be risky. Packet filtering. One of the primary functions of a firewall is packet filtering. It analyzes the header information of each data packet, such as IP addresses, port numbers, and protocol type, to determine if it meets the criteria specified in its rule set. Stateful inspection. Modern firewalls often use stateful inspection, which means they keep track of the state of active connections. This allows them to differentiate between legitimate responses to outbound requests and potentially harmful unsolicited inbound traffic. Application layer filtering. More advanced firewalls can also inspect the data payload of packets at the application layer. This enables them to detect and block specific types of content, such as certain keywords or malicious code, even if the packet's header appears legitimate. Describe what is meant by the term packet filtering pass, and explain why firewall software makes use of it. Merit. Packet filtering refers to the process of selectively aligning or blocking data packets based on specific criteria as they pass through a network interface, such as a router, firewall, or network gateway. Each data packet contains information about its source, destination, protocol, and other relevant details. Packet filtering examines this information and makes decisions on whether to permit or deny the packet's passage. The term PAS stands for Packet Address Security System, which might be a specific implementation of packet filtering or a concept related to secure packet filtering. Firewall software makes use of packet filtering as a fundamental security mechanism for several reasons. Network security. Packet filtering is an essential aspect of network security as it allows firewalls to control the flow of data packets by filtering and restricting packets. Firewalls can prevent unauthorized access to a network, protecting it from malicious or unauthorized communication attempts. Access control. Firewall software uses packet filtering to implement access control policies. Network administrators can define rules that determine which types of packets are allowed to pass through the firewall and which are denied. For example, specific ports can be blocked to prevent certain types of network traffic. Defense against threats. Firewall packet filtering helps mitigating various cyber threats, such as denial of service DOS attacks, port scanning, and intrusion attempts. By dropping or denying packets from suspicious sources or with malicious payloads, firewalls enhance the network's security, bandwidth management, in addition to security purposes. Packet filtering allows firewalls to manage bandwidth effectively. For instance, firewalls can prioritize certain types of traffic, like video conferencing or critical applications, while limiting less important or bandwidth-intensive activities. Describe what is meant by the term inbound and outbound traffic pass and explain different rules that can be set up for each. Merit. Inbound and outbound traffic, in the context of computer networks and internet communication. Inbound and outbound traffic refer to the direction of data flow between a local network, e.g., your home network or company's internal network, and external networks, e.g., the internet or another remote network. Understanding the distinction between inbound and outbound traffic is crucial for network administrators when configuring network security and firewall rules. Inbound traffic Inbound traffic refers to data packets or information that are coming from external sources and destined for devices within the local network. For example, when you access a website from your home computer, to data packets from that website server to your computer are considered inbound traffic. Outbound traffic, on the other hand, refers to data packets or information originating from devices within the local network and sent to external destinations on the internet or remote networks. When you send an email or request information from a web server, to data packets from your computer to the server are considered outbound traffic. Rules for inbound and outbound traffic. Network administrators can set up various rules to control and manage inbound and outbound traffic, typically using firewalls and other network security devices. These rules help protect the network from unauthorized access, malicious attacks, and ensure that only essential communication is allowed. Here are some different rules that can be set up for each type of traffic. Inbound and outbound traffic in the context of computer networks and internet communication. Inbound and outbound traffic refer to the direction of data flow between a local network, e.g., your home network, or company's internal network, and external networks, e.g., the internet or another remote network. Understanding the distinction between inbound and outbound traffic is crucial for network administrators when configuring network security and firewall rules. Inbound traffic refers to data packets or information that are coming from external sources and destined for devices within the local network. For example, when you access a website from your home computer, to data packets from that website server to your computer are considered inbound traffic. Outbound traffic, on the other hand, refers to data packets or information originating from devices within the local network and sent to external destinations on the internet or remote networks. When you send an email or request information from a web server, to data packets from your computer to the server are considered outbound traffic. Rules for inbound and outbound traffic. Network administrators can set up various rules to control and manage inbound and outbound traffic, typically using firewalls and other network security devices. These rules help protect the network from unauthorized access, malicious attacks, and ensure that only essential communication is allowed. Here are some different rules that can be set up for each type of traffic. Research and evaluate how effectively firewall software improves the security of a network. Distinction. Title: Effectiveness of firewall software in enhancing network security. Abstract. Firewall software plays a critical role in securing networks by monitoring and controlling incoming and outgoing network traffic based on predefined security rules. This research paper aims to evaluate the effectiveness of firewall software in enhancing the security of a network. We will investigate its role in preventing unauthorized access, mitigating various types of cyber threats, and its overall impact on network security. The study will involve a combination of literature review, case studies, and practical experiments to provide a comprehensive analysis. Introduction 1.1 Background 1.2 Objectives 2. Literature review 2.1 Definition and types of firewalls 2.2 Firewall deployment strategies 2.3 Firewall technologies and features 2.4 Previous studies on firewall effectiveness 2.5 Limitations of firewall software. Methodology 3.1 Research design 3.2 Data collection 3.3 Experimental setup 4 Firewall effectiveness in preventing unauthorized access 4.1 Access control mechanisms 4.2 Intrusion prevention systems IPS 4.3 Virtual private networks VPNs 5 Firewall effectiveness in mitigating cyber threats 5.1 Denial of service DOS attacks 5.2 Malware and virus protection 5.3 Application layer attacks 6 Case studies 6.1 Company A Firewall implementation and security outcomes 6.2 Company B Firewall breach and consequences 7. Evaluation of firewall impact on network security 7.1 Metrics for measuring effectiveness 7.2 Effectiveness of different firewall technologies 7.3 Factors influencing firewall performance. 8. Limitations of firewall software and overcoming challenges. 8.1 False positives and negatives. 8.2 Advanced persistent threats. APTs. 8.3 Encrypted traffic and firewall inspection. 9. Best practices for firewall implementation. 9.1 Rule management and regular auditing. 9.2 Firewall configuration and updates. 9.3 Integrating firewall with other security solutions. 10. Conclusion. 10.1 Summary of findings. 10.2 Recommendations for enhancing firewall effectiveness.
Thanks for watching. For more information, like, comment, and subscribe our channel.